When it comes to radio transmission, we have something known as the Fresnel effect. So that's how it's spelled. It's a French name, so typically this S is going to be silent, but that's an aside how to properly pronounce this. What we need to remember is that, as we've been discussing, because of this Fresnel effect, it is entirely possible for us to have good line of sight, but to not have any radio line of sight. So let's imagine this here. You're here, so we're going to put you right there, and you are holding your transmitter. So let's draw a little person here, and we're going to draw that little transmitter right there. Meanwhile, over here, you've got your UAV. So here's our little UAV buzzing around, and of course the receiver is here. So over here I've got my transmitter, over here I've got my receiver. One of the things with a transmitter is that, of course, when it transmits its radio waves, most of them are going to be transmitting those radio waves out in every which direction. So that's in case if our UAV moves around. Now, the main line of reception is going to be, of course, directly from my transmitter right to my receiver, the UAV. So most of us will think, well, that's the most direct line to my UAV, so since I can see it, no worries. But there's a little bit of an interesting dynamic going on as well. This is the shortest path to get to our UAV. But remember, we've got little radio waves going every which way. So here's what can happen. If I have the ground here, right along like that, what can happen is some of these radio waves that are going off in different directions, they of course can bounce off the ground and work their way towards the UAV in a direction something like that. So what we've now got happening is we've got two signals arriving at our UAV at a different time due to all of this reflection. So, well, what does that mean? I don't want to complicate it too much, but what it means is this. Remember, radio waves go out in terms of literal up and down pulses. So if we took this here, we could actually see those pulses with a crest and a trough up and down as they propagate towards the UAV. If we happen to have, though, a radio wave that ends up being reflected off of the ground, well, what's going to happen is it takes a tiny bit longer to get to the UAV. So what will happen is maybe it will be so bad that this radio wave, okay, so we've imagined that this radio wave here, I've zoomed in on one of this, now let's zoom in on this as it arrives at the UAV. It could actually be like this. It took it longer to get to the UAV, so notice how the signal, the troughs and waves are actually directly opposite. So if I took a line through here and a line through here, these waves actually end up canceling one another out. So the poor UAV goes, whoa, wait a minute, no signal. Nothing's happening. So you can start to research this a little bit on your own if you would like. But this problem becomes even greater when we start to have something like this happening. Let's imagine that instead of perfectly straight ground, let's imagine this, that I've got something like maybe a hill in the way. This can actually make things a lot more challenging. So now we've got a hill in the way, something like that. So now you can start to imagine those radio waves as they start to get to your UAV. It can really, really start to mess things up. So what happens mathematically is this. If I start to consider all of these radio waves working their way towards my UAV, I actually end up with what is known as this Fresnel zone. And it works out that it is actually roughly shaped like a great big long cucumber. It's a cylinder shape, so something like this. And what happens is if I've got any objects right inside of that Fresnel zone, it's going to make the likelihood of losing the radio signal much greater. So what you'll actually do is try to ensure that there's no objects between you and your UAV, even if they may appear to be below your visual line of sight. Things like buildings in here could make things difficult. For that matter, let's imagine that we have a series of trees in here as well. Maybe if the trees are outside of the Fresnel zone, so there, won't be an issue. But if we've got trees up through here, yeah, that's going to be an issue. You can also see I've blocked my line of sight now, so maybe that's not the best diagram. But anyways, it's important to remember that any obstacles inside of that zone, the Fresnel zone, could potentially cause your unit to lose communications. The radio line of sight might not be the same as the visual line of sight.